All right, in this video we're discussing the best practices to use when creating a histogram. All right, so let's start with the main idea of a histogram. What is its purpose? Well, the purpose of a histogram is to display visually the distribution of data. So it's to give us a hint or a look at what the distribution of data looks like. So here, when we look at this, we say, oh, this is kind of bell-shaped almost, right? So it looks almost like the cross-section of a bell, right? If you cut a bell in half, it has that sort of shape to it, right? So that's interesting. It's definitely a mound shape, right? Like a hill, right? And it's not perfectly symmetric, but it looks, somewhat symmetric. So it's kind of interesting, right? And we get a feel for, again, where the kind of grades break down in this class, right? It looks like between 60 and 80 is the dominant area for where most of the grades are. And relatively few people get scores up here or grades down here. So this class apparently has a maximum grade of 130 and probably a minimum of 0, but we don't have any grades of 0. So they've kind of cut off the axis there. So what are some of the characteristics that make it a well-designed histogram? Well, for one thing, they have a uniform class width down below. Notice how it looks like every rectangle here corresponds to about 10 points, right? So from 20 to 30, 30 to 40, 40 to 50, so on and so forth. And if you look at this vertical axis, they've used percent as the label. So rather than list the frequencies, they use percentages. That's good because let's say this is a class of size 50 and then I have another class another year that's of size 200, you'd want to make sure you could compare the histograms for those two classes directly. And if you use the counts of the frequencies, that's going to be hard to do. But if you use percentages or relative frequency, it's going to be much easier because now it's the percent, So if I say, well, geez, it looks like about 27% of my class got a grade in the 70s here, then I can make a comparison between this class and a class in the future that has a different number of students, right? And I can just compare the percent that fall into that range, right? If it's a frequency, then I have to go ahead in my head or I have to go find out how many people are in the class and convert it into percents to make a meaningful comparison. So it's best to use percent and relative frequency here. All right, the other most important thing is that this is visually representative of what's going on in the frequency distribution itself. So I said that this rectangle appears to be at a height of about 27, right? So it's showing about 27% here. Well, that means that I would like this rectangle here, this blue rectangle between 70 and 80, to be about 27% of the area of this overall histogram. In other words, if I calculated the area for each of these rectangles and added them all together, I would want the area of this individual rectangle to be about 27% of that total area, because that's what it's supposed to be representing, about 27% of the data, right? So that's very important that those things are proportional that way. If not, the graph will be misleading. Typically, you won't have a problem with that as long as you use percents here on the vertical axis and you use uniform widths. However, there are times when you don't want to use a uniform width for all your classes. For example, you might summarize this as over 100, right? And group these three things all into one class. In which case the class width for that one would be 30, whereas for the others it was only 10. If you do that, you can no longer use percent on this axis. You have to use percent divided by whatever unit you measured your x-axis values in. In this case, it would be points, right? So percent divided by points or something. And then you'd have to then make sure the heights of the rectangles were solved for by using a simple algebraic equation representing, the area of a rectangle, and using basically algebra to solve for the desired height. So you know how high to draw those things on your y-axis. I'm not going to get into that because it's not really the main focus of our course, and probably most often you would let a software package create the histogram, but it's just that general idea that you want to make sure that your histogram is not misleading anyone, right? So if you draw this by hand and you make that mistake of using class widths that aren't uniform, and then you use an axis label like percent on the side, the combination of those two things will often create a misleading drawing. In other words, it'll make maybe that last rectangle way too massive, and it'll make it look or appear as if it's more common to end up in that class or category. So you want to avoid that. So basically try to use uniform class widths when you can, and then you can go ahead and use a nice simple label for the y-axis of percent. But either way, if you let software do it, it should take care of it. Just remember the most important feature is that whatever area this rectangle has, it should correspond to its relative frequency in the frequency distribution. In other words, if this is 25% of the data supposedly, then it should be 25% of the overall area of this histogram. And that's the idea.